Hello, welcome to my home. Today we're going over the last page of the second test on derivatives I gave, so we'll just get started. So the first part is if x squared y minus 3x is equal to y cubed minus 3 at the point negative 1, 2, what is dy dx? Now this is set up like a perfect, straightforward, implicit differentiation problem, so we'll do that. This first chunk is a product rule use. So by the product rule, it is the first x squared times the derivative of the second, which is dy dx, plus the second y times the derivative of the first, which is 2x. Now we move on to this minus 3x. The derivative of that is just minus 3. And then on the other side, we have a power rule. So this is 3y squared times the derivative of y, which is dy dx, and then derivative of 3 is just 0, so we don't worry about that. Now, if we were trying to get a compact expression, we do some simplification here, but we're not. We want it at just one point where we have both x and y. So we're going to plug in our x and y. X is negative 1. This becomes negative 1 squared times dy dx plus y is 2, so we have 2 times negative 1 minus 3 equals 3 times 2 squared dy dx. Great. Negative 1 squared is 1, so that's just dy dx. Then we have 2 times 2 is 4, times negative 1 is minus 4, minus 3 equals 2 squared is 4, 4 times 3 is 12, dy dx. A little bit of algebra here. Subtract dy dx from both sides and collapse these together. We get negative 7 equals 11 dy dx. And with some division, we get that dy dx is equal to negative 7 over 11. Great. Moving on. Find the equation horizontal asymptote of y equals 3x minus 4x to the fourth over 10x to the fourth plus 7x squared. Now, this is not a calculus problem. If we really wanted to, we could approach this as a limit problem. If it makes more sense in your mind, you're trying to find what the limit as x increases without bound is, y. But that's really not necessary here. Like, we're going to look at this, and we're just going to look at this, and we're finding the term of the highest degree in the numerator. That's this one. And we're finding the term of the highest degree in the denominator. That's this one. And as x is getting bigger and bigger, this doesn't matter, and this doesn't matter. So we are looking at, well, what is negative 4x squared, x to the fourth, over 10x to the fourth. Since these are both x to the fourth, they cancel out completely. We get negative 4 over 10, which is, of course, negative 2/5. Hooray! That is going to be our horizontal asymptote. If you want to wrap it up nice, technically horizontal asymptotes are lines. So if you need the equation of horizontal line, it's y equals negative 2/5. This is the properest answer. Moving on. This is the problem that when I administered the test, I, for whatever reason, couldn't read what I had created and thought it was written wrong, but it wasn't. So we'll actually be doing this twice, once as it was written, which is this way, and once as the way I corrected it. Both, if you answered one way or the other, both of them counted correctly, just so you know. So we look at this, and we got a complicated thing we're finding the derivative of. We need to find out what like the innermost and the outermost thing is. And the outermost thing is we're taking this and we're raising it to the third power. So the outermost thing is a power rule. So we apply the power rule. 3, whatever's on the inside, which is x squared minus cotangent of x, to the second power, right? Now you have to multiply that by the derivative of what's inside. So the derivative of x squared is 2x, and the derivative of cotangent is negative cosecant squared. Now, since we already have a negative, those negatives canceled, so we'd say plus cosecant squared x. And then there's not really anything else to do. That's it. Okay, moving on. Now, this one is find the derivative of, now notice the difference here is that instead of being a straight chain rule problem on the outside, this one is just separated by negative, and we've moved that to the third power to the inside of cotangent. So we can treat these bit by bit. Derivative of x squared is 2x. Most people can get that at this point. Now this one we have to work outside in, so derivative cotangent is, of course, negative cosecant squared. That negative cancels out, so it's plus cosecant squared. This stays the same because we haven't applied the chain rule yet. Now we apply the chain rule, we have to multiply by the derivative of the inside, so times 3x squared. And that's it. Again, I accepted both tactics. It was fine either way, and so I decided to show both of them. Moving on. All right, this was the multi-part problem. It was meant to replicate all the problems I've given you up until this point were meant to replicate an AP test, the multiple choice kinds of problems. This is meant to replicate a free answer type. So for the whole question, f of x is equal to the square root of 25 minus x squared, where x is defined from negative 5 to 5 inclusive. And to start, we just find f prime. Okay. When you're doing that, you'll probably want to take this square root. If you don't have the derivative of square root itself memorized, you want to change that into 25 minus x squared to the 1/2 power. And then use the product rule, power rule. So that becomes 1/2 25 minus x squared to the negative 1/2. Then we multiply by the derivative of the inside, which is negative times negative 2x. Interesting things happen. The 1/2 and the 2 cancel. And if you want to rewrite this back using root notation, which some people like doing, this would then be negative x over the square root of 25 minus x squared. Now I have this written down for myself because we're going to use it on the next part. So the next part asks us to find the equation for a line tangent to f when x is negative 3. Now, I think I explained this in an earlier video. Whenever you see a line tangent to, right, we need two things. We need a point and we need a slope. We have half of the point. We know x is negative 3, so we need the other part of the point. So we'll do that first. We want the square root of 25 minus negative 3 squared, which is the square root of 25 minus 9, which is the square root of 16, which is 4. So our point is negative 3, 4. All right. Now we will go at our slope. Now if you turn back, the slope is just equal to the derivative at negative 3. If you turn back to the other side, we already found the derivative. So this just means we have negative 3 over the square root of 25 minus negative 3 squared. Now, again, we can reuse our work. We already know what this part is. We just did it. It's over here. This part is 4. So this becomes 3/4. That's our slope. So when we want the equation, we still need the equation. We have the parts. We're going to use point slope. So y equals 4 plus 3/4 times x plus 3. And that will be a good final answer. Moving on. Now, here, reminding you a little bit of ideas of continuity and piecewise defined function. So we have another function g. Oh, I didn't change it for here. Anyways, we have a new function g, where g is just equal to f when x is between negative 5 and negative 3. and it's equal to x plus 7 when x is from negative 3 to 5. Okay, and so we ask, is G continuous at x equals negative 3? We'll use the definition of continuity in your answer. Well, yeah, so pay no attention to this. We'll find what we'll find what G of negative 3 is. Because for continuity, we need that the function exists at the point, and that's equal to the limit at the point. So we'll start for what the value is at that point. You can define it with this. It's negative 3 plus 7, which is equal to 4. Hooray. So we need to, so that's the value of the function. Now we need the limit. So the limit, if it exists, as x goes to negative 3 of g of x, add two more parentheses, since it's piecewise defined, we have to look at the limit on both sides. We already know on this side, the limit as x goes to negative 3 from the positive side, that'd be this one, is going to be 4, because it's just what we got over here. And then if you turn back to the previous problem, part B, x is negative 3 there. Strange. So we know what this is from the negative side. It's also equal to 4. So that means that g of negative 3 is equal to 4. And the limit as x goes to negative 3 of g of x is also equal to 4. So by definition, G is continuous at x equals negative 3. All right. And then finally, what is the shape of the graph of f of x? We're back to f of x. We're not on G anymore. I don't think that tripped anyone up, but that's just so you know. This is, yeah, it's a little bit trivia, but you should know what the upper half of a circle looks like when it's as in algebra. So this is the upper half of a circle. It has a radius of the square root of 25, which is just 5. Negative 5, 5, and 5. It is an upper half circle, and I'm not good at drawing yet. All right. And that's it. Thanks for tuning in. I hope this helped, those who needed it, and I'll be doing more videos on other things soon.